So with this for question 5, right, it says here clearly the graphs of f of x. So we can easily see that f of x is a parabola because of this. So obviously this is telling us that the turning point is going to be -1, coordinate -8, because for the x value of the turning point, we always take the opposite of this. The y value of the turning point, we always take this number as it is. This is clearly an exponential graph, so that's all good. They say these two graphs are represented in the sketch below. And then they say P and Q. There is P over here. There is Q over here. These are the x-intercepts of F. And R is the turning point of F. So there's R over here. We already know what the coordinate of R. It's going to be -1 and -8. And you can see this is already on the negative side of our Cartesian plane. And we know for sure it's -1 because of this value here. We said for the x value of the turning point, you always take the opposite of this value. So already here, we can already see that the x value here is going to be -1. And then here they said A is this coordinate. It is a point on the graph of G, which is our exponential graph. All nice, all dandy. For one single mark here, they said write down the equation of the axis of symmetry. So getting the equation of the axis of symmetry is also something we already have here, because the axis of symmetry will pass through the x value of the turning point. Now, its equation will be based on the x value that it cuts, because this is a vertical line going straight down. So the equation of a line like this one, you'll always say x is equal to whatever x value it is cutting on the, what you may call, on the x-axis. Let us re-add our fallen comrade, and then we shall carry on. Admit, let me just help you out here. Ha ha ha. So let's see. With the next question, right? It says here, write down the coordinates of R. We already mentioned what the coordinates of R is going to be. It's going to be -1 because of this. We take the opposite, and then this we take it as it is. So here we're gonna say R is just -1 and -8. Because remember, this format here is in the form y is equal to a x minus p squared plus q, you see. So your p value, the opposite of this thing here and this as it is, this will always be your turning point, you see. So that's why we have R immediately. That's why it's also a 1 mark question. They want us to now get the coordinates of P and Q. P and Q are the x-intercepts of our graph of F. So remember, for you to get the x-intercept, you have to make y 0. So this is our equation of our graph, right? F of x is equal to 2x, is equal to 2, and then x plus 1 here, squared, and then -8. So we have to make this equation equal to 0, because we're trying to solve for the x-intercept. So for you to end up with 2 values, right, or 2 answers, you have to be careful here, in the sense that here, this square here, you want to be careful when it comes to getting rid of this. So for now, we can take the 8 to the other side. It becomes a plus there. And then we can divide by 2 on both sides. Dividing by 2 here, dividing by 2 there. Here, 8 divided by 2 is a 4. And then here, these 2 cancels these 2. Then you have x plus 1 here squared. Now, the big idea here is that when you're going to get rid of the square root symbol here, this is where you need to make sure that you end up with 2 answers. Meaning if you square root this side and you square root this side, here this square root is going to cancel that. But then here, you have to have 2 answers. You see, plus or minus 2. And then since you now have plus or minus 2, it means you need to split up your page. One side, you work with the +2. The other side, you work with the -2. You see, that's how you're going to get 2 of your x-intercepts. So here, the 1 goes to the left. Then you're going to have 2 minus 1 there. And then x has a +1. Here, the 1 goes to the left. Here, you're going to have a -3. Which definitely kind of makes sense, because if you have a -3 here, and you have a +1 there, it's a valid answer, because remember, from your axis of symmetry until 1 x-intercept, the distance here should be the same on the other side. So you can see here, this is like 2 units apart. You see 1 unit, 1 unit. Same here, you see 1 unit, 1 unit, because from -1 all the way to -3, you're gonna go 1 unit and then 1 unit, you see. Here you're gonna go 1 unit and then 1 unit. So your answers are definitely okay. But then here you see they want the coordinates. So you cannot just leave answers like this. Here you have to say, therefore, P, as we can see, it's on the left side. So the x value is -3, but the y value is 0. So -3 here, give a 0 there. Q, same idea, +1 and 0. Whoop. Let us add our comrade once again. Gigs. Stop video, just wait. Is it the same person? I don't know. Anyways, for 2 marks here, right? They said we should determine the equation of the inverse of G in the form Y. So getting the inverse of G, it's not a hassle at all. Here is just a half to the power of x, right? That's the original equation. So if your original equation has a half to the power of x, remember inverse just means that you swap around x and y, you see. So let's just say it like this. G of x becomes x, x becomes, no, let's just make it simple, you know. Y becomes x, x becomes y. So that being said, here we can easily put an x there, and this we can make it to the power of y. And then, because we're trying to get the inverse, remember, we're trying to isolate the exponent. Anytime you're trying to isolate the exponent, you have to use logs, you see. So in terms of isolating the exponent, you isolate it, you make it on its own, and then the base of the exponent, you make that this value there for your log. And then whatever this x is, it's just gonna still be there. You see, now that's your answer. You can maybe write the y first. You see, y is equal to log the half over here, the x over there. And then you're gonna get your 2 marks. You're gonna get 2 nice marks there. And yeah, that is that. 5.5 is a 3-mark question. This 3-mark question says we should sketch the graph of the inverse, right? So sketching the graph of the inverse, it's not going to be difficult at all. The reason why sketching the graph of the inverse is not going to be difficult is because as long as you have the original picture, your life will always be good. Because if we just draw this original picture on our sketch, drawing the inverse will be easy. You see, so this is the original picture. I'm just drawing the original picture so that drawing the inverse is a bit easier for us. You see, so this is what the original picture looks like. Now, for you to draw the inverse, right, all you need is the line of inverse. Remember, the line of inverse is the line y is equal to x, and it's this line over here. So as long as you have this line y is equal to x, which you should draw it out when you draw the inverse of the graph, as long as you have this line of inverse, drawing the inverse of your original graph should not be a hassle, because all you do is you have to remember that your inverse is a reflection about this line, meaning all you want to do is, what I normally do is just, for example, look at where this is, right? So if this is here, if you're going to reflect it about this line, right? So whatever this distance is, it should be the same going that way. So you should have your arrow somewhere there. And then for this arrow here, you can see if you go directly to your line of inverse, you see, whatever this distance is to the line of inverse, it should be the other way, going like that, you see. So you know your other arrow is there, because you see here, these should be mirror images of each other, and then this should be mirroring there. So now your graphs should also always meet each other on the line of inverse. So with all this information, you can easily draw your curve. See, oh, that was going so well until my fingers started doing things, but let's see. Let's move that, do it a bit better. There we go. Let me put a nicer arrow here, and then we'll have our images. So that's what you can do whenever you need to draw the inverse. Just make use of your line of inverse, you see, because remember the idea is this distance here is the same there, and then this distance here is the same there, you see. So as long as you can remember that, you're good to go. These, you can see it's a mirror image of each other. Same here. So they should just be mirroring each other. And then this, remember, we don't need it, the original one. We just drew it so that it can help us draw the inverse, you see. So it's something you can always do for yourself. And then we can just label the inverse, you see, g -1 x. And then you'll get yourself 3 good marks. You can label the x-axis, can label the y-axis. And then, yeah, life is good, LG. So with 5.6, it's a 2-mark question. They said for which values of x is the inverse of g bigger or equal to -2. So a question like this needs you to make use of the equation of your graph and the picture. Well, you don't necessarily need the picture, but the picture will help you, because this is just asking you where are the y values of the inverse bigger or equal to -2. So firstly, you can just think to yourself, where would the y value -2 be? So -2 would be somewhere over here, you see, just an estimate. So if your y value of -2 is like somewhere here, this is where your y value would be -2, right? So if we look at the question again, this is asking for which values of x is the y value below -2. So what we can see is, if you're going to work out where the y value is below -2, what you can see from your picture is that this portion here is the part that is below -2. So this part that is below -2, it's going to be x values starting over here, going to positive infinity. The x values starting from here, those are the x values that are going to be producing these y values that are below 2. So what we need to do is to find out the x value here. And then as an answer here, we'll be able to say the x values need to be bigger than whatever this x value is. So finding this x value, it's not a problem at all, because if you're going to find out where something is, oh, no, I'm mixing it up. This is asking where is it above -2. Yeah, let me change my words. They're asking us where are the y values above -2. So they're above -2 here. This is the part where the y values are above -2. So here the question is asking for which x values are the y values above or equal to -2. So that's happening between 0 and whatever this x value is, because clearly between this x value and 0 here, that's the portion where your y values are bigger than -2. So for us to answer our question, we have to find out what is this x value first. Now to find out this x value, we just have to throw -2 into our equation of our inverse. And we have the equation of our inverse, you see. Let's see here, y, let's go to log, a half here, and then here we have x. So we need to find out where the y value is -2. So we're gonna put -2 over here. Solving for x here, it's not difficult at all, because remember, in this format, we know that this is an exponent, this is a base. So you're gonna have your base as a half, exponent as -2, and then x on its own, you see. And then here, this is something you can put in your calculator, you see. A half to the power of -2 is going to give you a 4. It's gonna give us 4. Is it gonna give us a 4? Yes. So this x value here is a 4. What that means is the x value here is a 4. This is just a 0. So we know that the y values are above -2 from 0 until 4, because as long as you're considering x values between 0 and 4, those x values are going to be producing these y values over here. See, so let's give that as an answer. So here we can say x is between, let's just say here, x is the element of 0 until 4. Here we have to put a square bracket at 4. because specifically at 4, the graph is equal to -2, which is what this question also says. You see, the question wants us to get where is it above 2, or where is it equal to where is it above -2, or where is it equal to 2? So that's how we answer this question. We have to put the square bracket for the 4. The reason we're putting the round bracket for the 0 is because specifically at 0, the graph will never touch 0. You see, so we're saying between 0 and 4, where 0 is not included, the 4 is included. Now, the way we have answered this question, right? We didn't make use of our sketch very much, but we located it. The next question, though, is definitely going to need us to make use of our sketch, because these kinds of questions, right, you don't necessarily work them out algebraically. You actually work them out using a diagram. So in our diagram here, right, what they're asking us is, where will this expression be a number that is smaller than 0? That's the question that is being asked here, you see. So with a question like this one, right, you need to be careful, because a question like this is basically asking you, two things are being multiplied together. What will result? What values will make this left side a negative? Now, the one way to always work questions like this is to think to yourself, there's one thing over here, and then there is another thing over here. You see, so two things are being multiplied together. The only way you'll have a negative value coming out is if one of them is a plus while the other one is a minus, or if this one is the minus while this one is a plus. You see, it's all a matter of determining, okay, where will this one be a positive number while this one is a negative number? Where will this one be a negative number while this one is a positive number? Because as long as that's happening, this will always be a negative, this will always be a negative. Now, with questions like these, right, for you to answer them properly, you also definitely need the sketch, because let me actually have the sketch somewhere down there so that we don't keep scrolling up and down, because as long as the sketch is like directly next to us, a question like this will be much easier to understand and much easier to explain, you see, because pictures make the world go around. As long as you have a picture, yeah, life is good, you see. So if you're looking at our picture here, right, let me just clean it up a bit, because we don't need all this other information for now. Do this, do this. So with our picture here, this is actually our picture of, is this our inverse? Yes, that's our inverse. Wait a minute. We're talking about f of x, not g of x. Well, that makes life a bit different. Let's just delete this image, because this is the graph of g. I'm not realizing now that, wait, that's the graph of g. We're talking about the graph of f. I guess it kind of makes sense that we're talking about the graph of f, because we really haven't made use of f. Does somebody want to say something or not? I think I heard something. Oh, well, I guess it's sorted. So anyways, we have this parabola here, and that's the graph we're basically working with. Yeah, the sketch here, it doesn't look very pretty. It actually looks terrible. Let me actually try and do it better. Hello, did someone forget their mic on? Or not? Anyway, so with this next question, we need to make use of the graph of f of x. So this question is literally asking us, where will this expression be giving us negative values? So the only way you're going to get a negative value here is if you have negative x values while having positive y values. Because remember, this is representing y values of f. This is representing y values of f. This is representing x values. So technically speaking, this is saying your x values multiplied by your y values. Where will this be a negative number? So all we need to do here is we can actually use colors to help us. Let's color code this image. Here I'm coloring out where you have positive y values. This is where you have positive y values. This is where you have positive y values. And then let's just add our comrade here. Admit. So here, this is where you have positive y values. This is where you have positive y values. And then obviously below that, this is where you have negative y values. Here you also have negative y values. Now, obviously, if you look nicely, this part here, you have positive x values. And then to the left, you have negative x values, you see. So the red is representing positive y values and positive x values. The yellow is representing positive x values. I mean, is representing negative x values and negative y values. So when it is color coded like this, it kind of makes our life a bit easier. Let me actually do something better by making this a bit thicker. So this is positive y values, positive y values. And then going to the right, this is positive x values, you see. Now the yellow is representing negative x values and negative y values. I think this is much better to look at. So when you have a picture like this, answering your question here becomes a little bit easier, because all we have to do now is we need to look for portions of our sketch, right? Where we, for example, have positive x values while having negative y values, you see. So let's do that. So here we can see positive x values are here. So we want where we have positive x values together with negative y values. And that's only happening between here until there, you see. This x value, we know it's a positive 1. This x value, we know it's a 0, you see. So what we can see is between 0 and 1, that's a portion where you have positive x values together with negative y values, you see, which is a portion that's going to definitely give us a value that's a negative value here. Because if you put a positive x value here and a negative y value, these two multiplied together will give you a value smaller than 0. So the first portion of our answer, we're going to say x is an element of 0 until positive 1. The 0 and the 1, they are not included because specifically at 1, you have a y value of 0 there. Specifically at 0, you have an x value of 0. So if any of these is a 0, if you multiply them, you just get a 0. And 0 is not smaller than 0. So this is the first portion of your answer. So we want here also, you see, we want where you have negative x values together with positive y values. And that is happening from here, going all the way to negative infinity. From here, going all the way to negative infinity, we can see that you are going to be having positive y values here while having negative x values, you see. So that portion definitely qualifies for our answer. So we're going to say here, x element of negative infinity until positive, until negative 3. That value, we got it to be a negative 3. Let me just draw this a bit better. Negative infinity until negative 3. So again, infinity will always be not included. Specifically at negative 3, you have a y value of 0 there. So 0 times anything will be a 0. So if any of these is a 0, you cannot get a value smaller than 0. That's why we have to not include the negative 3 there. So for this question, right, for 3 marks, that's what we're going to have to say. These are our 2 answers, you see, because it's just asking where the x values times the y values giving a number smaller than 0. And here, as long as you have color coded it, you can easily answer your question, because all we're looking out for here is a portion where you have red and yellow together, and then another side, a portion where you also have the red and the yellow happening at the same x values, you see. So that question will give you 3 marks. Do this, do that.